Hey, this is Mr. Drogemeyer. Thanks for joining me for our Algebra 1 Unit 2 test review. Today we're going to be looking at all of the different properties of polynomials that we talked about in Unit 2 and get you prepared for that unit test. So let's go ahead and jump in. And our first question here says that when they're multiplied together, which of the two polynomials that we have listed below are going to equal this expression that we have, x to the fourth y plus 2x squared y. So if we think about multiplying two of these together, so we've got the 2x squared y, we could take it times this x squared y. If we did that, we would get 2x to the third y to the third. We'd only have one term there. So one thing we can notice right away is that one of these has to have two terms in it so that we're distributing. So that means that we're going to be taking A times either C or D, or we're going to be taking B times either C or D. And so let's take a look at A if we multiplied it by 2x plus y. Well, first of all, you can see if I take 2xy squared times 2x, that's going to give me 4 for the coefficient. So I know right away that it can't be A and C. Let's see if it could be A and D. What if we take that 2xy squared and we multiply it by x squared plus 2? Well, 2xy squared times x squared, that would be 2x to the third y squared. Well, that doesn't match up here. So we know that A isn't going to be one of them. It has to be B that we're multiplying by either C or D. So if I take B times 2x plus y, my first term, I would have 2x squared y times x would be x to the third y. Well, that doesn't match here. So it looks like we're going to be multiplying b times d to get that particular expression. Let's go ahead and check it just to be sure. So if I take it times x squared plus 2, x squared y times x squared, that would be x to the fourth y, and then x squared y times 2, that would be 2x squared y. And so b and c are the two polynomials that we would multiply together to get the expression that they gave us. All right, moving on then to number 2. In number 2, they ask us which of these expressions are polynomials. And when we talked about for something to be a polynomial, one of the things that we said we can't have a variable that's inside of a root symbol. So in this one, the square root of m prevents this expression from being a polynomial. We also said that that our exponents have to be whole numbers. And so here we have an x to the 1/3. That tells me that's not a polynomial. If I look at these other two, that would be a polynomial. It would be a monomial. And then this one, we have multiple terms, 4 different terms. Everything looks good there. That would be considered a polynomial. So again, the things we can't have a variable in a root, and we have to have whole number exponents. Moving on to number 3. In this one, it asks us what are 2 possible ways that we could factor this expression n to the fourth plus 5n to the third. Well, if we're looking for a greatest common factor here, and they both have a variable n. One has an exponent of 4, one has an exponent of 3, so I could factor out n to the third. And if I do that, n to the fourth divided by n to the third, that leaves me n to the first, or n, and then 5n to the third divided by n to the third is just 5. So n to the third times n plus 5, that would be one factored form. Uh, and I just want to show you another possibility here would be I could factor out a negative n to the third. And basically that's just going to change the sign of everything inside the parentheses here. So technically I could factor it either of these ways. I would usually factor it the first way because that's the simplest way of looking at it, but I just want to show you that I could make that a negative as well and factor it that way. All right, moving on then to number 4. Which of the following expressions are factorable? So we want to look through these and see if I could factor them. They all start with a coefficient of 1. And so when we talked about those, we said we're looking for, when we factor it, two numbers that when we multiply them together give us that C term of 15 in this case. When we add them together, they give us that middle term, middle coefficient of b, which is 8. And so let's start with our factors of 15. It's a positive 15, so that could be 1 and 15, negative 1, negative 15, 3 and 5. Or we could also have negative 3 and negative 5. Well, if we look at those, want to see if any of them add together to give us 8, and you'll notice here 3 and 5, that does equal 8. So A is factorable. It would factor to x plus 3 times x plus 5. All right, same thing. Let's look at letter B. Looking for factors that multiply to 4 and add up to 6. Well, if we think of positive 4, we could have 1 and 4, negative 1 and negative 4, and then we have 2 and 2, or negative 2 and negative 2. Well, if we add those together, none of those are going to add up to 6, which is what our B term is there. So that one does not factor. Letter C, we want factors of 9 that would add up to negative 7. So if we think of positive 9, we'd have 1 and 9, negative 1 and negative 9, and then 3 and 3, or negative 3 and negative 3. Those would be our factors. If we add those together, nothing is going to add up to negative 7 there. So that one will not factor. And then if we look at our last one here, we're looking for factors of negative 36 that would add up to negative 9. So negative 36, I could have 1 and negative 36, negative 1 and negative 36. Excuse me, negative 1 and positive 36. I'm just going to put plus there. 2 and negative 18, negative 2 and positive 18. We could have 3 and negative 12, negative 3 and positive 12, 4 and 9, negative 4, excuse me, 4 and negative 9, negative 4, positive 9, and then finally we would have 6 and negative 6. All right, so a lot of different factors here. We started right there. Looking for something that would add to negative 9. Well, if we look through here, if I add positive 3 and negative 12 together, that would equal negative 9. And so this does factor. It would be x plus 3 times x minus 12. And so A and D here are my two expressions that are factorable. All right, moving on then to number 5. And in this one, they ask us to factor this expression, 6x squared plus 7x minus 20. So this time we do have a leading coefficient that's not 1, it's something other than 1. And when we talked about these situations, we had some steps to go through. We first wanted to see, is there a GCF, a greatest common factor? In this case, I don't have a GCF. So then my next step is I'm going to look at my a term and my c term, multiply those together. 6 times negative 20 is negative 120. And so I'm looking for factors of negative 120 that when I add them up are going to give me that b term, that middle term of 7. So if we think about factors of negative 120, so one's going to have to be positive, one's going to have to be negative. Let's just go ahead and list them out. So 1 and negative 120, or negative 1 and positive 120. I'd have 2 and negative 60, negative 2 and positive 60, 3 and negative 40, negative 3 and positive 40, 4 and negative 30, negative 4, positive 30. 5 is also a factor. So if I take 5 times negative 16, or negative 5 times positive 16, and I just did that wrong. Give me 1 second here. Sorry about that. My mental math was failing me there. So not 16, that would be 24. Let me clear that off here real quick. Sorry about that. There we go. So 5 and negative 24, negative 5 and positive 24. We have 6 and negative 20, negative 6, positive 20. Our next one would be 8, 8 and negative 15, negative 8, positive 15. And just looking through these, I could continue going. I'm looking for a positive 7 in the middle. And if you notice here, my negative 8, my positive 15, add those together, and I get that positive 7 in the middle. All right, once I have those two numbers, then I'm going to replace that middle number, or sometimes you'll hear it called split the middle. So I'm going to take that plus 7x and I'm going to rewrite it using these two numbers that I had, and I can choose the order I want to put them in. I'm going to use the plus 15 here, minus 8 here, and then minus 20. And now what we're going to do is we're going to factor out a GCF from the first two terms, and then do the same thing for the second two terms. So 6 squared, or 6x squared plus 15x, the greatest common factor here, 6 and 15 are both divisible by 3, so I can factor out a 3, and then both of those have an x, so I could factor out a 3x, which would leave me with 2x squared, or excuse me, 2x plus 5 in the parentheses. 3x times 2x is 6x squared. 3x times 5 is 15x. And then the second two terms, negative 8x, negative 20, I can factor a negative 4 out of each of those. That would be my greatest common factor. Negative 4 times 2x is negative 8x. Negative 4 times positive 5 is negative 20. And so notice this is the point we want to get to. We have the same expression inside the parentheses, and so that allows us to rewrite it, since I'm multiplying 3x times the 2x plus 5 and negative 4 times the 2x plus 5. That's the same as multiplying 3x minus 4, put those into parentheses, times that 2x plus 5, and this is my factored form for that expression. All right, let's move on, take a look at number 6. So another example here of factoring. We want to factor this expression, 8x squared minus 72. First of all, I want to see, do we have a GCF? Because again, we have a leading coefficient that's something other than 1. Well, 8x squared and negative 72 are both divisible by 8, so I can factor out an 8, which leaves me with x squared minus 9. Well, if you notice, x squared minus 9, that's a difference of squares. That was one of those special cases we talked about. X squared is a square, 9 is a square. And so when we have a difference of squares, the square root of x squared is x. The square root of 9 is 3. This is going to factor to x plus 3 and x minus 3. Another way of thinking of this, if you didn't recognize right away that that was a difference of squares, well, we could still use our process before. That last term, we're looking for factors of negative 9. And since we don't have an x term in the middle, our x term is 0. So we're looking for two numbers that multiply to give us negative 9 and add up to give us 0. And I apologize, I just got interrupted by a phone call and I'm not sure where I left off. So again, hopefully you got that. The factors of negative 9, we would have negative 1, positive 9, positive 1, negative 9, and then 3 and negative 3. Well, the 3 and the negative 3 add up to 0 in the middle. So hopefully, I know that was a little disjointed, but hopefully we got it there. So, all right, moving on then, let's take a look at number 7. And in 7, we want to factor our expression here. So again, looking for a greatest common factor. And in this case, 4 and 64 are divisible by 4. And I can factor out either negative 4 or positive 4. I'm going to go ahead and factor out negative 4 to make that first term positive. That would leave us with a squared minus 16. Negative 4 times negative 16 would give me 64. And again, this is a difference of squares. So our difference of squares there, square root of a squared is a, square root of 16 is 4. So this becomes a plus 4 and a minus 4 is the factored form. And again, we could do the same thing we did on that last one, find the factors of negative 16 that add up to 0 since we don't have a middle term there. All right, on to number 8. In number 8, they ask us to combine like terms to simplify this expression. All right, and so for this one, if we're looking for our like terms, I have, so like terms, same variable, same exponent. Here I have a negative 3c and a positive 6c. Those would be like terms. This c that's inside of the parentheses, I'm not going to include that as a like term because that whole expression is being squared. So I can't just combine this c with the other c's that are out here because it's of that, the parentheses and the exponent there. And then my 5 and my negative 7 would be like terms, and then the same idea with the 3 there. I can't combine the stuff that's inside of that parentheses because it's being squared. So to combine these, I'm going to leave that expression that's in the parentheses the way it is. And then I have my c terms, negative 3c, positive 6c. Add those together, I get a positive 3c. We add the coefficients and keep the variable. And then the 5 and the negative 7, add those together, I get negative 2. And so this would be a simplified form of that expression. All right, moving on then to number 9. And in this one, they ask us which expression has a greater value at x equals negative 2. So we want to evaluate this expression when x is negative 2. And we have 3 different ones here. So we're going to plug in negative 2 for x. So in our first one here, I'm going to do that over here. Negative 2 squared minus 4 times negative 2 plus 6. Well, negative 2 squared, negative 2 times negative 2 is positive 4. 4 times negative 2 is negative 8. And then we're adding 6 here. Well, if you're subtracting a negative, that's the same as adding a positive. So 4 plus 8 plus 6, 4 plus 8 is 12, 12 plus 6 is 18. So our first expression evaluates to 18. Our second one, plugging in -2 again, -2 squared is 4. 4 times -2 is -8, so we're adding a -8 here, and then plus 6. Well, 4 plus a -8 is -4. -4 plus 6 is +2. So that one evaluates to +2. And then our last one here, -x squared. So the negative, and then we have -2 squared, then minus 4 times -2 plus 6. All right, so -2 squared is still 4, but that's like -1 times that +4. So it becomes -4 here. And then I have 4 times -2 is -8 plus 6. Well, so again, subtracting a negative is the same as adding a positive. So -4 plus 8 is +4. 4 plus 6 is 10. All right, so we've evaluated all three. Our first one here has the greatest value at x equals -2. All right, so let's move on then to number 10. And in number 10, it says we have three different polynomials given below. When x is 2, are there any of these polynomials that are equal to each other? So again, we just need to evaluate these when x is 2. So in that first one, we're going to take 2 to the third and add 2. Well, 2 to the third, 2 times 2 times 2 is 8. So that's 8 plus 2. It evaluates to 10. Our second expression, we're going to plug into for each case of x here. All right, so we're going to start in our parentheses. So 2 plus 3 is 5. And then here, 2 minus 2 is 0. We're going to do our exponents of 5 squared is 25. So this is 2 times 25. And then here, 2 times 0 is 0. So it's 2 times 25, which is 50. And then our last one here, we're going to plug in 2 for x in each case. So it's a little more complicated. All right, so 2 minus 2 is 0. Inside my parentheses, 2 squared is 4. 2 times 2 is also 4, plus 3. And then here, 4 times 2 is 8. 8 plus 2 is 10. Well, notice here, 0 times anything is 0. So we have 0 plus 10. So this one also evaluates to 10. So our answer, 3 and 1, would be equal to each other when x equals 2. All right, a few more here. Number 11. This expression, 9x squared plus mx plus 64 is a perfect square trinomial. So what is the value of m? All right, so if we want to find what that value of m would be, to find that middle term m, we're going to take the square root of this coefficient and the square root of the last, the c. So the square root of 9 is 3. The square root of 64 is 8. And then when we multiply those together, we get 24, and we need 2 times that. So our number is going to be 48, and let's see why that works. So if I had, excuse me, or let's do it this way. If this is going to be a perfect square trinomial, I'm saying it's going to be 3x plus 8 squared. So when I multiply those out, so 3x plus 8 times 3x plus 8, 3x times 3x is 9x squared. 3x times 8 is 24x. 8 times 3x is 24x. And then finally, 8 times 8 is 64. And so when we add those together, 24x plus 24x is 48x. And so to get that middle term, we take 2 times the a term times the c term, that coefficient. So 48 is our number here. All right, and number 12, similar problem here. We have perfect square trinomial. We want to know what c would be here. Well, that first term is going to be 7. Square root of 49 is 7. So what is our term here for c? What's this number need to be to where we would get a negative 28 in the middle? Well, remember we said it's 2 times the 7 times whatever this last number is to get 28. So that tells us that that has to be a negative 2, because 2 times 7 is 14. 14 times negative 2 is negative 28. So if I have 7x minus 2 quantity squared, that should give me our expression here. Let's check it out. So 7x minus 2 times 7x minus 2. 7x times 7x is 49x squared. 7x times negative 2 is negative 14x. Negative 2 times 7x is negative 14x. And negative 2 times negative 2 is a positive 4. When we add those middle terms together, we get our negative 28x. And so c in this case would need to be 4 to make that a perfect square trinomial. All right, number 13 asks us to explain if these two terms, 6m to the fifth n and 6n m to the third, are like terms, and why or why not? Well, in this case, we would say that they are not like terms, because although we do have the same variables, those variables do not have the same exponent. So to be like terms, they have to have the same variable raised to the same exponent. And so that would be our explanation. To be like terms, they have to have the same variable raised to the same exponent. I'm not going to write that out, but that's how you would go about explaining that answer. All right, our next one here, we have this expression 3x squared times 6x times 5. Will the product change if the order of the quantities being multiplied changes? So what they're saying here is, am I going to get a different product or a different result if I change the order? So what if I did 6x times 3x squared times 5, for example? Would that give me a different product or a different solution than if they were done in this order? And so our answer here would be no, it's not going to change the product. And the reason is what we learned in our properties, the commutative property of multiplication. So in your explanation, you would want to mention that commutative property of multiplication says that changing the order of the terms doesn't change the product. So that would be, you'd want to have mention that property in your expression, or excuse me, in your explanation, saying that changing that order isn't going to change the product. All right, next one here says a student factored this expression 4x squared minus 16x minus 48 and gave an answer of 4x plus 8 times x minus 5. Is this student correct? And explain. So if you multiply those two binomials together, the 4x plus 8 times the x minus 6, you would see that you do actually get 4x squared minus 16x minus 48. So on the surface, it looks like the student has factored it correctly. But if you notice, notice that 4x and 8, they have a greatest common factor of 4. So I can actually factor this further. So the mistake that they made here is that, if you remember, our first step should always be to see if we have a greatest common factor. And if you look at our expression here, we have a greatest common factor of 4 that we could factor out of all of those terms. And that would leave us with x squared minus 4x minus 12. And now we can factor from here. This one is going to factor to x minus 6 and x plus 2. And so this is going to be our simplest form, our factored form. So in explaining why the student wasn't correct, we would want to say that he or she didn't factor out that greatest common factor of 4, and so they didn't have the solution factored completely. All right, and then I believe this is our last one, number 16. Is this expression 2x squared plus 7x minus 11 factorable? And we want to explain. So we have a leading coefficient of 2. Look first for a greatest common factor. We don't have a greatest common factor here. So our next step then is we're going to multiply a and c together. 2 times negative 11 is negative 22. So then we want to find factors of negative 22 and see if any of them add up to that middle term of positive 7. Well, 22, I could have negative 1, positive 22, positive 1, negative 22. I could have negative 2 and positive 11, positive 2 and negative 11, and I believe that's all of our possible factors there. And so then we want to see, do any of these add up to positive 7? And our answer here is no. This one is closest, gets to positive 9. But so we would want to say that it's not factorable. And the reason is that when we couldn't find any factors of negative 22 that add up to positive 7. All right, and I believe that is our last one. And it is. I appreciate you taking the time to watch the video. I hope that it helps you feel more prepared for that unit test. As always, if you do have questions, please let me know. Thanks. Have a great day.